Question 58 is probably the most complicated in your homework assignment because it has heavy math. Physics-wise, it's not very different from what we have done before. So we have, again, a projectile that is launched at an angle. We don't know the initial speed. At the moment when the ball is thrown, we have a receiver who is 10 meters ahead from where the ball was thrown. And the questions that we have to answer are the football's initial speed, the amount of time the football spends in the air, the distance between the quarterback and the receiver when the catch is made. So this whole, basically the distance between the receiver and the person, if it is caught at the same height, so that is your total displacement of x, if you think about it. One more thing, we know that the receiver is running at 5.5 meters per second. Let's do the first thing first. We're going to separate x and y as per usual. In the horizontal direction, v0 times cosine of 25 is vx. In the vertical direction, v0 times sine of 25 equals Vy initial. We also know that change in x1 is 10 meters. We know the V of the receiver is 5.5 meters per second. And that looks like is all that we know. How do we go about this? We need to figure out the initial speed and the amount of time that the football spends in the air. So let's think time. During the time that the football spends in the air, we have 10 plus 5.5 times that time in the air would give us the horizontal range. Let this sink in for a second. What I'm talking about is while the ball was in the air, it traversed the horizontal displacement that will equal 10 meters, the distance between the receiver and the quarterback, plus the distance that the receiver is going to run during that time while the ball is in the air. So the total 10 plus this 5.5 times time in the air will give you change in x. And it will be equal to your v0 cosine of 25 times the same change in t in the air. Hopefully this will make sense. The problem with this equation though, I have one variable, two variables. One equation, two variables. That's not solvable. I need something other than that. What do I know vertically? Apart from g equals v final minus v initial over change in t, not much. So if I figure out half the time, which will be 0 minus initial velocity vertical divided by negative 9.8, 1 for that matter, that should give me change in t in the air, half of it. Time in the air is going to be twice v0 sine of 25 over 9.81. Now I have two equations, two variables, that is quite possible to solve. And because the first question is about the football's initial speed, I'm just going to substitute time in the air and go for v initial. 10 plus 5.5 times 2v0 sine of 25 over 9.8. That is this expression for time, placed instead of time in that equation upstairs. It should be equal to v0 cosine of 25 times 2 v0 sine of 25, all of that, over 9.81. To get rid of my 9.81, I'm going to multiply everything by 9.81. And from your pre-calculus time, you should remember that this equals sine of 50. If you don't remember, you're welcome. I just told you. I'm going to say v0 squared times sine of 50 minus 11 times sine of 25 times v0 minus 9.81 equals 0. So what I'm going to do, I'm going to graph this and see what zeros I have for my v initial. I'm going to write it out so you know what it is that I'm graphing. So 0.766, which is sine of 50, times v squared minus 11 times sine of 25 gets me 4.65 of v0 minus 9.81. Sorry, that is 98.1. That would have been a boo-boo. That is the equation that I'm going to graph. So v0 is 14.8 meters per second. That is the speed with which the ball is originally launched at the moment the quarterback throws it. B, the amount of time the football spends in the air. Remember, it's going to be twice 14.8 sine of 25 divided by 9.81. That's not a lot of time, 1.28 seconds. Now for the final question, the distance between the quarterback and the receiver when the catch is made, basically the total change in x. That's what they're asking for. 5.5 times 1.28, solving it through the distance run by the receiver during the time that the ball was in the air, plus the 10 original meters that were between him and their quarterback. And your other solution could be down through the ball itself. So 14.8 cosine of 25 times 1.28, that gives you 17.2 meters. Not that big of a difference, it's just in rounding. So those are your answers to question number 58, the most delicious question on this homework.